Welcome back everyone. In this video, I'm going to show you how to compute average cost, marginal cost function, marginal revenue function, and we'll also talk about how to minimize average cost and maximizing profit. So those are the concepts we will be discussing in this video. So let's suppose C of Q, let that stand for cost function. So if you have some cost function, and let's say R of Q be the revenue function. So if you know these two functions, then we can do some calculus on them and figure out different components, such as average cost. Let's say the average cost of something will simply be the cost function divided by Q, where Q represents the number of units we're producing. So that's one of the formula we have to know for average cost. Then if you want to find, let's say, marginal cost, marginal, it's another terminology for derivative. So if you tag in marginal with the cost, that means you're looking for the derivative of the cost function, which is C in this problem. So therefore you can say this is simply C prime of Q. That's another way to write that, prime notation. Similarly, if we tag in marginal revenue, you're looking for the derivative of the revenue function. Well, then what is profit? Well, profit, we're going to define that as the function P of Q, which simply be the revenue function minus the cost function. So that's the formula we're going to use for profit. So knowing these ideas, let's see if we can do a few problems. Let's go ahead and work out this problem. So we're given the cost function right here. So C of Q represents the cost function. So Q represents the chocolate bars that this company is producing. Let's find out the average cost function. So for A, the average cost, it's going to be the cost function divided by the number of units. That is simply just 1800 plus 0.12 Q plus 0.003 Q squared divided by Q. That is our average cost function. Now, of course, you want to simplify this, so divide each term from numerator divided by Q. You get 1800 over Q plus 0.12 Q over Q, that's just 0.12, and 0.03 Q squared divided by Q is 0.003 Q, since one of the Q cancels from the bottom. That is our average cost for this given model. Now for the second part, we want to compute the marginal cost. So the word marginal means derivative of the cost function. So the derivative of the cost function respect to the variable Q, it's going to be, by using power rule, we know derivative of a constant, that's simply 0. And then derivative of 0.12 Q will simply be 0.12. Plus, now the derivative of the last term, 0.003 Q squared, you bring down the power, so that's simply 0.003 times 2, Q to the power 2 minus 1, that's 1. And if I clear this up, this is equal to 0.12 plus 0.006 Q. So that's the marginal cost function, simply the first derivative of the cost function. Now let's take a look at this problem. So we're given that the cost function in terms of dollar producing Q lamps, it's going to be designed by this model. And we want to know how many lamps the company need to produce in order to minimize the average cost. So we're pretty much looking for the derivative of the average cost and setting it to 0. So minimizing something or maximizing something means compute the derivative, set it to 0. So first you need to find the average cost. So the average cost, as we saw earlier, it's simply the cost function divided by Q. So that is going to be our average cost. So this is 810 divided by Q plus 3Q over Q, that's just 3, plus 0.02 Q squared divided by Q, that's simply Q. That's the average cost. Now if I want to minimize the cost, I would have to take the derivative of the average cost function, which is C of Q over Q, and set it equal to 0. Then we solve for Q. Q is the number of units that need to be produced in order to minimize the average cost. Okay, so we know the average cost is this formula we just obtained. So we're taking the derivative of that. So that's going to be, let's set this up. This is going to be 810 over Q. Now if you want, you can write that as a power, so we can use power rule just like that. Plus 3 plus 0.02 Q. And then we're going to set that to 0. So if I take the derivative using power rule, I bring down the power, I subtract 1 from the power, that's negative 810 Q to the negative 2. Derivative of 3 is 0, and derivative of 0.02 Q is simply 0.02. We're setting it to 0. And then algebraically we'll move things around. We can solve for Q. So I'm going to add 810 Q to the negative 2 to the other side. And that would give me 0.02 is equal to 810 Q squared. Q to the negative 2, I can write that as a Q squared on the bottom like that. And then we multiply both sides by Q squared, assuming Q is not 0, to cancel Q from the bottom. And that gives us 0.02 Q squared is equal to 810. And then we simply divide both sides by 0.02. That gives us Q squared is equal to, so 810 divided by 0.02, that's about 405,000. And then take the square root on both sides. Q is equal to the positive square root, because it's quantity that we're looking for, square root of 405,000. And if you put this in your calculator, you will get about 636.39. So we can say approximately 636 units production of lamps will minimize the average cost. Now let's go ahead and try this problem. So again, we're given the cost function, and in this problem we're also given the revenue function right here. So we're given two different formulas for two different things. And for the first part, we want to write down the profit function of this manufacturer. As we saw earlier, the profit function P of Q is simply the revenue minus the cost function. So we know the cost function is given as this formula, revenue is given as that formula, we just subtract them. So this is equal to revenue, that is going to be 16Q minus 0.002 Q squared, and we're subtracting away the cost function. So put parentheses around so you can distribute the negative out. That's 2500 plus 4Q plus 0.005 Q squared. That will be the profit function. So go ahead and distribute the negative, and you'll have 16Q minus 0.002 Q squared minus 2500 minus 4Q minus 0.005 Q squared. Now by looking at like terms, we can combine them. 16Q and negative 4Q, these are like terms. That gives us 12Q. And negative 25 doesn't have like terms, so we can keep it as it is. And the last like term we have is these guys, so they seem to be like term. So if I combine them, I get, so negative 0.02 minus 0.005, that's about negative 0.007 Q squared. So that is our profit function. All right, now let's go ahead and find the marginal cost and marginal revenue. Well, those marginals are just the derivative. So marginal cost, that's going to be the derivative of the cost function. And marginal revenue, that will be the derivative of the revenue function. So let's go ahead and compute them by using power rule. So for the marginal cost, that's the derivative of the cost. So I differentiate 2500, that's 0. I differentiate 4Q, that's 4. And I differentiate 0.05 Q squared. Well, that will simply be just 0.010 Q. So that's our marginal cost. And then for marginal revenue, we take the derivative of the revenue function. So R prime of Q, so if I take the derivative of 16Q by power rule, that's just 16 minus the derivative of the second component. So using power rule, we have 0.004 Q. So that would be our derivative of the revenue function, which we're calling marginal revenue. All right, so I hope this is making sense. Now for the last part of this problem, we're asked to find how many supplies should the manufacturer produce to maximize profit. Again, every time you hear maximize, minimize something, you think of the derivative of that function, set it to 0. So in this case, we're going to take the derivative of the profit and set it equal to 0 because we're looking for maximum profit. We know what the profit function is, so that's the one in blue. So for part C, we take the derivative of the profit function and we're setting it to 0, and we solve for Q, meaning the item we need to produce to maximize profit. So let's take the derivative of the one in blue. So derivative of 12Q, that's simply 12. Derivative of 2500, well, that's going to be 0. And the derivative of negative 0.0707 Q squared, bring down the power, that would be negative 0.014 Q, set it equal to 0. And then when we solve it, so I can add 0.014 Q on both sides, and that gives me 12 is equal to 0.014 Q. And finally, we divide both sides by 0.014, and that gives us the number of Q we need to produce to maximize profit. So Q is equal to, if you put this in your calculator, you'll get about 857.14. So approximately 857 supplies in this case to maximize profit. So that's how much unit this company needs to produce in order to maximize profit. All right, I hope these ideas make sense. I will see you next time.